Alright, we're now going to build the synchronous counter, and we're going to use it doing JK flip-flops. Before we do anything else, I do want to note that I can build either synchronous or asynchronous with the D flip-flops, or I can build it with JK flip-flops. The difference is in the type of flip-flop I use. The difference is how I do clocking. Synchronous means everything, all the flip-flops are sharing the same clock into their clock. Asynchronous will mean the output of one flip-flop actually feeds the clock of the next. So this is my schematic, and I'm going to have 1, 2, 3, 4 JK flip-flops and 2 AND gates to control them. This is synchronous because the clock is shared by all of them. So what I'm going to do before I do anything else is go hook that clock up. All the clears and the presets are all connected to one. So we're going to connect all the clears and all the presets to one. Before I build any circuit, I'm just going to get my JK flip-flops to work. So this is my 74 LS 76, 2 of them. In between I have a 7408, which is my 2 AND gates I'll need in there. I've already provided power and ground for each. Reminder that power is 1, 2, 3, 4, 5, pin 5. And ground is pin, let's see, 8, 9, 10, 11, 12, 13. 9, 10, 11, 12, 13 for the 74, 76s. I'm going to turn these on. They will get warm very quickly if I wired anything wrong, so I'll make sure that they're okay. Now I'm going to go through, and I think I said I would do clock, but I think I'll do the clears first. So when I look at my JK flip-flop, pin out, which hopefully you have in front of you, but I'll produce it. So preset is 2, clear is 8, preset is 7, clear is 3. So 2, 3, 7, 8 all need to go to 1. So what I'm going to do then is I'm just going to go in here and I'm going to so I'm going to take 2 and 3 and connect them together. I said 2 and 3, that's not 2 and 3. There we go. 2 and 3, connect them together. And again, a really nice short wire that's pre-cut would be beautiful for this. And you have them in your wiring kits. I don't have them sitting here. Okay, 2 and 3 are connected. This one feels like maybe I didn't get it connected. And 7 and 8 are connected. Sometimes it's frankly just a little easier to do them like this. And instead of trying to put them right next to each other, just stagger them a little. In fact, maybe I'll do that on these. And those need to go to 1. To keep my board clean so I'm not jumping stuff all the way across, I think I'm just going to go ahead and connect these right into my power, which is pin 5. And again, okay. So all those should be 1 there. Now I'm going to come back. I'll show you here in a second how I probably want to, give those a quick double check. I'll do the same thing. I said 2 and 3. Seven and 8 connected together, and then we'll connect those into the power. We need one more. I think I'm one little red wire short of what I need, so I'll do that real quick. Now, a reminder, I use this term systematic a lot, and it's key to making this stuff work. We don't build up everything and then try to test it and just hope it works in the end. We're going to test bits as we go along and make sure they're working okay before we move on. So I'm just going to do that real quick here. And the easiest way to do that, lost my power there. Easiest way to do that is to get my logic probe. So I'm going to go check. I've hooked up and I've moved a lot of wires around. I'm not even going to bother going on until I'm certain I have power everywhere. Okay. So I should be ground. should have power into the chip, and that these, once again, I'll double check. 7, 8 are preset and clear, and 2 and 3 are preset and clear. 2 and 3, 7 and 8. Oh, here they are in the end. I missed 1, 7 and 8, and power. So I got power all the way along where I should. I'll double check my AND gate in the middle. So I went through it, and I've got power, and I should have my presets and clears already set. So presets and clears, already logic 1. Clock. So all 4 of these need to share a clock. So clock is 1 and 6 for my JKs. I'll use these whites I have here. So I'll go from 1 to 6. So both those JKs have the same clock. And likewise, I'll do a little wire here I can't grab. There we go. 1 to 6, and you know, I am starting to kind of jump it around a bit, I know. And then I'm going to take it, stretch all the way so my clock is the same for all of them. And rather than trying to attach multiple things up to the actual clock, I'll just jump them all down here. And now I need a clock signal, so I'll do that. Those long green ones I had from before, I'll plug into the clock. I'll run it down here, kind of out of the way of everything else, down to pin number 1. And now I should have the same clock on all those. And if I'm down at 1 hertz, then I should be good to even see it going on and off, since that's once per second. So let's just check that. So they ought to be the same. So I'm getting my clock into all 4 JK flip-flops. Alright, now I'm ready to build my actual circuit. That's just the setup. Okay, so output of the first Q is just Q0. I'm sorry, the output. And so my output on my JK for that first one is number 15. So I'm going to come plug into 15. I'm going to run this up. This is Q0, so I'll put it on the far right. And if everything is working, that ought to be going for me. Let's see. Oh, I also need to take, I missed this before, J and K need to go to 1. So let's get that. J is 16, I'm sorry, K is 16, J is 4. So those also need to go to 1. And I'll tell you, there's no reason not to just hook them right next to the value right next door. So number 4, you see I'm starting to get a little bit of a mess, but 1, 2, 3, 4. My power's even coming down there. There we go. It is going, but it's just luck of the draw. So J should go to 1. That's my J, which is number 4. I'm just plugging it straight into power, which is 5. I'm going to take K, which is 16, and I'm going to hop it over the top. Not over the top, I'm sorry. I'm just going to take it from right here. Probably not going to see anything change in what's going on because it's just kind of defaulting to doing that, but there we go. Okay, so my first one is working. My second one, right here, J and K are connected together, and it comes from Q of the first one. So Q of the first one is pin number 15. It's my light, and it's going to run into the J and K, which is number not 11, 9, and 12. So I'm going to take and jumper 9 and 12 together. This is 9, 10, 11, 12. And those need to be connected directly to this J, so I'll just do that. So let's use these blues to show what my interconnections between the flip-flops. Okay, now my output Q is pin number 11, it looks like. So I'll take pin number 11. So 9, 10, 11 right here. And I'll run it up here, and that will be my Q1. 0, 1, 2, 3. So I'm counting now. Now I'm going to go add my next one on. So I'm going to go over to this flip-flop. Now I could just use, it might be easiest to hop this one over and go into the top JK where those connections are, but I'm not going to. I'm going to take this leftmost one, I say top, but the one that's got more on top. I'm going to come over to here. So let's take a look at our, so I'm going to take Q from this one, Q from this one, both go into an AND gate. So I'm going to pick an AND gate right here, and I'll pick this one right here where I have 13 and 12 as my inputs. And all I'm going to do is jump over there. Use a couple of yellow wires to show my jump. So this first Q is right here. The second one's here. I'm going to put this in the second one because it's the shorter of my two yellows, so I'll use it first. And that's either of these first couple of inputs. Okay, and this is the other output right here. So yes, it is true that you can look at like this output's going up to an LED, it's going into here, and it's also going into this AND gate. This is an AND gate. The output of that AND gate goes into this next JK. So I'll use another little yellow wire and jump that over. And the J and K for that particular flip-flop, when I look back at the pinout, are 16 and 4. So I'm going to take this output and go to 16, which is, this is a 16 pin chip, so it's right out there. And then I'm going to do 4. So I'm going to connect that one to 4. So 16 goes over the top to 1, 2, 3, 4. It's going to be this one right here that doesn't have anything in it right now. I don't know if you can see it on the screen, but when you see yours, you'll see that. Alright, now I need to take an output from that, which is, the output Q is 15. Five. 0, 1. So when I've done this, I've messed something up on this one. Let's see where we're at. I think it's probably just a connection. They usually are. So we'll count all the way through. 0, 1, 2, 3, 4, 5, 6, 7. Start over. Okay, I got one more to add. So let's see. If I go to my schematic, this very last one, I'm going to take the output of the last AND gate and the output of the last flip-flop and run to another AND gate. So I'm going to pick the second AND gate up top. What I'm going to do is use blue. So I'll take output from that output and I'll go into one of these inputs. And I said the other one was just going to come out of the same output that we came of the adjacent AND gate. I feel like I may have hit a wire, so it's not working. So if my LEDs stop working up top, then what I'll do is I'll go back and check. Usually it's those connections here or down here. Okay, now the output of this AND gate is going to go into my next J and K. So J and K for the other flip-flop, K is 12 and J is 9. So output of the AND gate into 12 and 9. Output. So let's go. I'll jump it all the way over here because I have a long one. 9, and I need to hook this to 12. You notice I've kind of tried to color coordinate each set of connections. Once again, I see a lot of students the first time around will really just get one roll of wire and go with it. That makes it really hard to debug. And these are hard anyways if you get to the end. Okay, so we said this goes from 9 to 12. 9, 10, 11, 12 is right next to that ground connection. Let's see if we can get in there. Douche. And the output Q is 10. So we'll take that output Q all the way to the top here. If I can just slip that over the top and not mess anybody up. About 10. 1, 2, 3, 4, 5, 6, 7, 8. Yes. 9, 10, 11, 12, 13, 14, 15. There we go. We've built our 4-bit synchronous counter using JK flip-flops, and we needed some AND logic. So we're going to go through and capture that it works properly, and then hook it up to the oscilloscope and look at it again, much like we did with the asynchronous D flip-flop. Capture what you can from that, see what you can. I do realize that that's something that's the second channels may be a little messy, but again, you can just grab something off the clock signal to have the clock signal, pull these out, hook them to channel 2, and look at what they're doing. Draw the best picture you can, find the frequency, make sure you turn this up to 1 kilohertz or 100 kilohertz, or it's probably even better to get those frequencies. And report back exactly what you get. I'm still analyzing how we're going to be able to pull that data a little more easily, so I want to see what you're seeing and what you're taking away from that. Alright, so we've built our counters. We're good to move forward and do more advanced circuits after this.